All right, so this afternoon, potentially a little bit later this evening, I'm not sure exactly when I'll get it posted. Your next homework assignment will be kind of showing up. So we'll cover everything from last week through this next week. It won't be due for about 2 weeks down the road. So you've got some time to kind of start working on it early. As we progress through material this week, you'll be able to answer more and more of the questions. Look pretty similar to kind of the first one. I'll get all the iClickers kind of up to this point uploaded this afternoon as well. You can kind of see where you're at on that. Excuse me. And I'll also be posting a pre-class video for you to watch before we meet on Wednesday. Okay. So I'll be asking you some iClicker questions at the start of class on Wednesday, kind of related to that video. So that'll show up on the YouTube page later today. Okay. Other than that, are there any questions for me before we jump into material here today? That should kind of cover the things I wanted to. So we left off talking about shifts in supply, shifts in demand, how those impact the equilibrium price and quantity. So we're going to kind of tackle a slightly different topic. It's related to demand and it'll be related to supply. And it allows us to think about that model a little bit more, but we're going to be able to kind of address some slightly different issues as well. So the idea that we're going to start talking about today is this idea of price elasticity. Okay? So we're thinking about a demand curve, and I'll kind of jump the gun here a little bit and give you an idea about what we'll be thinking about. So how elastic demand is, the word kind of elastic means how much it can move, right? How flexible or how responsive something is. So we're talking about price elasticity of demand. We're thinking about, okay, so when the price changes, we know that what's going to happen to the quantity demand? It goes, sorry, when price changes, the price goes down, quantity demanded goes, price gets smaller, people want to buy more, right? So as the price drops, our quantity demanded actually increases, right? We have this kind of inverse relationship, right? The price is high, people demand lower amounts than when the price is low. So the elasticity of demand is how responsive is this quantity demanded to price changes, right? So this could vary across goods, right? So we just kind of use a good one that's really responsive are gas prices, right? So you've got a lot of different options, right? You've got 4 gas stations on a corner. They're all going to, you can look at 4 different prices and whichever is cheapest, that's the one you're going to go to, right? So when they lower that price, you're really responsive, right? If those other people keep their price high, because there's a lot of availability of different gas stations in there. A really unresponsive, or what we end up calling inelastic, right? Not a responsive good, would be something like insulin, right? If I'm diabetic and I need insulin to, I'm kind of subject to whatever the price is, right? There's kind of a similar idea with EpiPens, right? Not too long ago, the price of EpiPens was like ridiculously high, and it's like, well, look, those people who need those have to pay that price, right? They don't really have an option. They can't decide, well, you know what, EpiPen prices went up, and I just got, I accidentally just ate some shrimp or something. Who cares? I'll just ride this one out, right? No, you have to pay that price. You're going to be unresponsive to price changes because you need that good. Right? So even if we don't want to think about across goods, the same demand curve, if we're at different points, we might think about there's different elasticities. Okay? So I'll give you an idea about kind of thinking about how elasticity might vary on the same demand curve after we kind of get a formula that allows us to think about how we calculate the elasticity. When we think about this demand curve, there's some responsiveness to price changes, and we want to be able to calculate that. So we're going to essentially try to find the percentage change in quantity demanded and the percentage change in price. Okay? So this is how I'm defining elasticity. Let's say that there's only a 10% change in price. And I don't know, quantity demanded changes by 100%. What that tells us is, well, there was a really small percent change in price, but that change in price caused a huge percentage change in the quantity demanded, right? So we would say that good is very elastic, right? Even small price changes cause the quantity demanded to be very responsive, right? And the way that our elasticity measure will pick this up, notice if I'm doing the percentage change in quantity over the percentage change in price, do something like 10 here. So the higher this elasticity is, that's representing that the percent change in quantity demanded was much larger than percent change in price, right? So higher elasticities of demand will represent kind of more elastic goods. Now, one kind of issue we're going to have here that I haven't really shown yet is, even though I wrote 10 here, that's not quite right? Because if I saw a percent change of 10% in the price, so let's say the price went up by 10%, what do I know has to happen to quantity demanded? It has to go down. So it would actually be, even though we saw 100% change in the quantity demanded, it was actually a decrease, right? So anytime we see a price increase, we're always going to see a quantity demanded decrease. So, and vice versa, if we see price go down, quantity demand is going to go up. So we're always going to have a positive and a negative, and so if I divide a positive by a negative, I get a negative. If I divide a negative by a positive, I get a negative. So this elasticity of demand will always be negative. So what we're going to do, we'll have it on the next slide here. All right, sure, I've got an example. So I use some different numbers, but let's think about we calculate this elasticity of demand, and I get negative 0.5. So this was an example where I saw a pretty big price change, right? A 50% increase, but quantity demanded fell by less than that, right? It only fell by 25%. So we would say this is a good that's relatively inelastic or not elastic, right? It's not very responsive, or at least the change in quantity demanded was much less than that percentage change in price. So we would say this is kind of a non-responsive kind of good. Now, it's always going to be negative, right? So we have to remember, I want to show you, I might go back here. Where is it at? There we go. So we're going to start using something which is called the absolute value, right? So if I put kind of these straight lines on either side of that fraction, we're going to say we're going to be taking the absolute value, which just basically makes it positive, right? So we know it's always going to be negative, but then after we take the absolute value, we know we'll only be dealing with positive values, positive numbers. So we'll go back, skip a bunch of stuff. I wanted to point that out now. So why is it negative? Because of this inverse relationship. So essentially what we're going to do is when we think about the elasticity of demand, it's still going to be that percent change in quantity demand over percent change in price. We're just going to be thinking about it, drop that negative sign. Okay. So in this example, we found negative 0.5, which if we take the absolute value, it's 0.5. Over here, we found elasticity of demand of 10, right, after we took the absolute value. So I mean, 10 versus 0.5, we could say that whatever good I drew on the board there, that's more responsive or more elastic to price changes than the good we had in the example in the slides. But what values are large, what values are small? We'll start to kind of break these down into ranges here in a second. Okay. So if we're trying to come up with what these percent changes are, we're going to first try to figure that out, and then we'll dive a little bit more into like what this elasticity is really telling us. So, if I think about the price going from $100 to $80, well, it fell by $20, right? However, 20 out of 100, that was a 20% decrease in price, right? If the price fell from $100 to $80, right? Yeah, it went down by 20, but since it started at 100, that was 20%. Right? You want to think about really what we're doing there is whatever value you start out at, right? So we started out at 100, right? The price fell by $20, so 20 over 100, represents 0.2, right? But to talk about things in percentage form, right? This tells us the fraction that 20 was of 100. Well, to get it as a percent, we would have to multiply it by 100, or move the decimal point 2 places. So that proportion of 0.2, right, the decrease in price we saw, is actually a 20% decrease. So that's where I'm getting this idea of a 20% change. Right? We started out at 100, it fell by 20. 20 is, 20 over 100 is 0.2, so it's 0.2 of the original value, which is 20%, right? Move that decimal point 2 places or multiply it by 100. However, if we went the other direction, right, going from 80 to 100, well, my price went up by 20, but my starting point now was not 100, right? I started at 80. So now that same $20 increase, right, this would be 0.25, multiply it by 100, would be a 25% change. So the issue is I'm really moving between the same two prices, but depending on the direction I go, it's going to be a different percentage change. Right? So what we're going to end up doing, and this is, if you were to go outside this course, you start doing some things like calculus and doing this on really like precise points along this demand curve. But the method we're going to use, and essentially it doesn't change any of the end results. It might change the math and numbers a little bit if we were to use calculus instead, but that's too hard. We're going to punt on that. We really are just kind of focusing on the principles, kind of the outcomes here. So we're going to use something that's called the midpoint method. Excuse me. So what we do with the midpoint method to kind of get at this idea that, well, look, I'm moving between the same two prices. I should have the same measure of elasticity there. Right? Along that demand curve, when I'm looking at the prices from 100 to 80, so maybe I'm somewhere like within this range, I want to calculate the elasticity of the demand curve in that range between the price of 80 and 100. But I want there to be one value. It doesn't matter if I start at 80, it doesn't matter if I start at 100. That portion of the demand curve, I should be coming up with a value that's the same elasticity measure for any value in that range. So what we'll do is look at what was the change in quantity, right? And divide it by the average change, the average value of quantity there. Right? So if I'm thinking about calculating the percentage change in price that I had before, we'll do it the same way. We'll take the change in price divided by the average price. Okay? So when I had that example where I was going from 100 to 80 or 80 to $100, the midpoint method says, okay, you want the percentage change in price there. Take the change in price and divide it by the average price. Well, the change in price, if we were going from 100 to 80, would be 100 minus 80. And we divide that by the average price. Right? So how do we find the average price? Well, that's where we just add the two values up and divide by 6. So here I get what? 20 over 90. I don't know what that word was, but you 0.222 repeated. We wanted to what percent change. 0.22 repeating. We then want this as a percentage, right? You can move that decimal 2 places and multiply by 100. It really doesn't matter when we're calculating this. If you really want to see this as a percent, like 0.22, you could multiply it by 100. But because this numerator we have as well, right, the percentage change in quantity, that's actually not going to be in percentage form either. That's going to be a decimal. When we divide those by each other, it ends up not mattering. So it won't look like, if you do the intermediate calculations, right, you see this 0.22, you're saying, well, it wasn't a 0.22% change, it was a 22% change. But if you're doing this formula all at one time, you'll never actually see that value anyways. But if you are thinking about what the numerator and denominator represent, it's like it's representing the percentage change just in decimal form. But because they're both in decimal form, when we divide them by each other, it kind of cancels out and gives us this nice elasticity measure. Right? We could multiply the top and the bottom by 100. That's not going to change the equation, and they're just going to cancel out anyways. Right? But if we are like given the percent changes, we can also plug them in percentage form as well, and it really won't change anything, right? As long as the units are the same, right? We have the numerator and denominator both being as a percent, or we have them both being kind of in decimal, right? We don't have really a units to the elasticity. As long as those units are the same in our numerator and denominator, they'll always cancel out. So we can use this method for find percentage changes in price, and we can just look at what points we're moving at on the between quantity demanded as well. So when I had this price change from 100 to 80, maybe the number of units sold, went from 200 to 400. Well, now I can use those values of 200 and 400, find the change in quantity there, find the average quantity, and come up with that numerator value as well. So we'll work through an example here of this. So if you want to break this down, I don't know. Sometimes it's like confuses people more. I mean, I think we know how to think about changes. What I'm doing to find the change, I'm really just taking the differences in the two quantities or the differences in the two prices. I didn't write that out here, right? When I said the price went from 100 to 80, I said, well, what's the change in price? Well, from going from 100 to 80, the change in price is just 20. Well, I can write that out. What did I do there? Well, I really took, what the first and second quantity was, and I had subtracted the one quantity from the other. How did I find the average? I want to write this out mathematically. Well, I took each of the quantities, I added them up and divided by 2, right? So that's what I had down there. How do we find the average? You just have two numbers. You just add those numbers up and divide by 2. So if we really want to write it out kind of technically correct, this would be the way we do it. Right? We'll have two prices. We'll have the quantities associated with each of those, quantity demanded, sorry, of each of those with each of those prices. And that's just a matter of plugging our values in, right? When we're thinking about the changes, right? Just the difference between the two quantities, the average, add the quantities up and divide by 2. So I kind of put some colors to these, right? So, this is how we write the change of price. This is how we write the change of quantity. Just trying to keep track of things. So let's go through a full example. Now, let's say I've got starting price. We see a price change. Think about how we do it. So what did I start out with here? I got an original price of $6, and the quantity demand at that point is 15. Right? I then see a change in the price, or I move to the second price of $4, and I see as I lower that price, the quantity demand has went up to 25. Okay? So visually, kind of what I'm thinking about here, black marker's dying on me. What I'm thinking about here is I'm at 2 points on this demand. First point is our price is $6, price of 1. And at that quantity, that price I had a quantity of 15. The next price is $4. And when I lowered the price to 4, quantity demand jumped up to 25. So if I'm drawing out the visual here, if I want to think about, here was my first price, here was my second price, here was my first quantity, here was my second. Now it's just a matter of plugging those values into my elasticity equation. Now, I've already kind of introduced, I think in the slides I have it, but up here on the board, right, where we talked about, ultimately, I'm just going to take the absolute value anyways, right? So I'll have some negative signs floating around up here, but ultimately it won't matter because at the very end, we're going to take the absolute value. But we'll work through it and then take the absolute value again. So you'll see those negative signs pop up in a minute. So the first thing we have is Q2 minus Q1, right? So I'll take my second quantity and subtract my first quantity, so 25 minus 15. That gives me that change in the quantity demand. And then I'm going to divide that by the average quantity, right, between those two values. So if I want to find the average between 15 and 25, it might be kind of intuitive, right? We're thinking about that middle value, there's 20. But how would we actually calculate, maybe if we had some more difficult numbers? We'd be adding up those two quantities and dividing by 2. So that's our numerator. I'm then going to divide that by the change in prices, right? So I take my second price minus my first price, so 4 minus 6. I then divide that by the average price between those two values. Once again, it's pretty easy here to see the average of 6 and 4 is simply 5. But if I had harder numbers, what I'm doing there is I'm just going to add up those two prices and divide by 2. So I'm just plugging my values into that equation. Now, if it helps, what I might do if it was me is we've got several fractions here. I might find the averages first and then write those numbers down. That way I'm not having to use parentheses in my calculator. You know, I could find, okay, the change is 10, write that number down, right? 25 minus 5, 15. The average, 15 plus 25 divided by 2 is 20. Do that and figure out, okay, my numerator is 0.5. Then go through the denominator. 4 minus 6 is -2. 6 plus 4 is 10 divided by 2 is 5. So divide that by 5. My denominator is -0.4. Now just 0.5 over 0.4, right? And then, so kind of breaking it down into parts prevents you from making as many mistakes, like entering it all in on one line and under the calculator. So that's a highly suggest kind of looking through it. So notice I've got 0.5 over 0.4, -0.4. So my elasticity is going to look negative. We already talked about in the last step is just kind of taking that absolute value, dropping that negative sign. So it'd be what? We're writing this down to be what, 1.25. Okay. So I think I have it in the slides here, right? I'll reproducing that. Kind of walking you through step by step how we get to that point. And like I said, it looks like it's negative here, but we're then going to add this additional step, which is we take the absolute value. Because we want to be able to come up with 3 different ranges. Okay? Before we move on to that, though, are there any questions kind of over this midpoint method, how you kind of proceed through it? Okay with this? All right, so really we're thinking about changes and averages here, kind of in that equation. So we want to think about 3 different types of elasticity. I kind of already mentioned, you know, is a good inelastic or elastic. We also have this third category of unit elastic. So before we actually start thinking about these ranges, I said we're going to actually take the absolute value. So all the method that we use to calculate elasticity is all the same. Excuse me, let's actually come with the final value. We need to take the absolute value, just drop that negative sign. So if I see a good where the elasticity of demand is less than 1, we say that's an inelastic good. Okay? And the reasoning why, I'm not sure if you got that result, but I'm thinking about percentage change in quantity demanded over the percentage change in the price. That's less than 1. I actually rearrange this equation and multiply both sides by the percent change in price. This cancels. 1 times anything is the same. So all I'm left with is the percentage change in quantity demanded is less than the percentage change in price when that elasticity was less than 1. So all I did there is I started out with, right, the percent change in quantity demanded over the percent change in price is less than 1. I'm just going to move this to the other side. So I multiply each side by the same thing. This cancels. 1 times anything is itself. So I know that when a good is inelastic, the percent change in quantity demanded has to be less than the percent change in price. But also, if I just look at the equation, maybe I can kind of, don't have to get too lost in the kind of this proof, I guess. But if I'm just thinking about looking at this, when it's inelastic, what is that really telling me? The only time this fraction can be less than 1 is if the denominator is less than, or sorry, the numerator is less than the denominator, right? The only time this is less than 1 is if the numerator is smaller than the denominator. So really, when will that be the case? Whenever the percent change in quantity demanded is less than the percent change in price. Right? This is what I have over here. And this kind of makes sense because if I have really large percent changes in price, let's say the percent change in price was 100, percent change in quantity demanded was only -20, right? And take the absolute value. But you can see here, like, we have really big changes, percent changes in price, but relatively like smaller percent changes in the quantity demanded. Well, that's saying when the price went up a lot, people didn't buy that much fewer of the good. They were pretty unresponsive to that price change. Or we say that demand, if it's unresponsive, it's inelastic, right? Elastic meaning responsive, so if it's not responsive, it's inelastic. Questions on, this is kind of, elasticities are tough to think about. You just start tripping people up a little bit here. So if you have any questions or want to hear something clarified, don't be afraid to say. Are we just so lost we're not sure? Right? Okay, we'll talk about the other ones and hopefully we kind of really mention the same things. Will hopefully sink in a little more. So what if I have it be unit elastic, right? So if I have elasticity of demand is now, instead of being less than 1, let's say it's exactly equal to 1. What's the only way I could end up with unit elastic demand? I'm looking at that fraction. What's the only time that would be equal to 1? Or, I'm sorry, I should say. If I have two numbers and I'm dividing one by the other, what's the only way that fraction is equal to 1? Same number, right? If I divide 2 by 4, 4 by 2, that's never going to equal 1. I have to be dividing whatever number this is by the exact same number in the denominator. So the only way I end up with a unit elastic good is if this percentage change in the quantity demanded is exactly the same as that percentage change in price. Right? So there, it's almost like you're saying, well, however price changes, quantity demand is just changing in a 1-to-1 ratio. It's exactly responsive. You change the price by 20%, the decrease or the increase in price by 20%, decrease in quantity demand will be exactly 20%. It exactly matches that percentage change in price. So that's what we would call unit elastic. And the last category is that elasticity of demand greater than 1? So same kind of idea. What's the only scenario? If we have the percentage change in quantity demanded over the percentage change in price. In order for that to be greater than 1, what has to be true about the percent change in quantity demanded relative to the percent change in price? Yeah, the only way this is greater than 1 is if the numerator is larger, or that percentage change in quantity demanded is greater than percentage price. So why does that represent the elastic part of demand? Well, think about it. If I'm having a small percent change in price, and then the percent change in the quantity demanded, or the percent change in the amount that people want to buy goes up by more than that, well, that means a really small percent change in price caused a really large percent change in the quantity demanded. People were really responsive to whatever that original price change was. So that's why these three ranges are what they are. It's elastic when the change in quantity demanded is even greater than the original percent change in price. It's inelastic when the original percent change in price was greater than how much people responded in terms of how much they demanded. And then if it's a 1-to-1, they exactly, percent change in quantity demand is exactly the same as the percent change in price. We say that's unit elastic. And that was this kind of theory. Now, we don't usually see things that are perfectly unit elastic when we look at the actual data. But, right, when we start to talk about some other issues, we can imagine where that point might be. Like it does exist. It's just unlikely we see exactly one. We can probably get really, really close to it. Any questions on any of this before we keep moving? Okay. So we've got our three ranges, right? We'll start thinking about the demand curve in elasticity. So when we look at a demand curve and kind of downward sloping, it might be initially we want to think about slope represents the elasticity. It's not quite, like it's not that steeper demand curves have higher elasticity. They're related, but it's not the exact same thing. In fact, on the same demand curve, right, we can see that elasticity is actually different on different points of that demand curve. In fact, some demand curves will have elastic portions where demand is elastic, and other portions that'll be inelastic on the same demand curve. So a good rule of thumb, though, if we're trying to like visualize elasticity, is the steeper the curve, kind of the, well, let me draw it here. It'll make more sense. See the visual. This is the first one, so it shouldn't be this one. If I'm thinking about here, if I saw a really steep demand curve, and slope is not synonymous or one-to-one with elasticity. It's a good place to kind of think about and visualize what elasticities are. So let's say here, where's my starting price? We'll call this P1, P2, P1, P2, and I'll go out of the way. Okay. We don't have to walk through all the values. We could actually think about some values and compare differences. Really, the visual, I think, does it all first here. If we looked at here, the percent change in price was pretty big, right? The percentage change in quantity was relatively small, right? So this would be the idea that when we have a really steep demand curve, right, huge percent changes in price cause really small percent changes in quantity demand. So huge percent change in price, really small percent change in quantity demand, we'd have an inelastic demand, right? So a real steep demand curve represents actually less elasticity or more inelastic. Two different ways of saying the same thing, right? If something is less elastic, that means it's more inelastic. We're just kind of using prefixes there to say it a little bit. Let's see here. So if I want to think about extreme examples, right? So this first one, I did like the most extreme example possible. So I said when this the slope gets steeper, that means it's more inelastic, right? Or that elasticity is becoming smaller and smaller, closer and closer to that 0 point. So you can kind of imagine if I had like the most inelastic good ever, a perfectly inelastic good. What would that imply? If it was perfectly inelastic, when I saw percent changes in price, what would happen to percent change in coin demand? So that's unit elastic. If I had the most, so instead of saying perfectly inelastic, so not confuse those two things. If I had the most inelastic good ever, remember, elasticity means responsiveness. So if it's inelastic, it's not responsive. So we're thinking about how is the quantity demanded responsive to price changes. So if it's the most inelastic, huge percent changes in price would actually cause the percent change in quantity demanded to be almost 0, right? So you can see here, I could see huge, right? Or I guess here I didn't make it that huge, 10%, but I could see, here I could see 3,000% changes in price. And what happens to the change in quantity demanded? Well, if it's a perfectly inelastic good, that means demand will never change regardless of the price. So if I then have a percent change of 10 or a percent change in price of 10 and a percent change in quantity of 0, my numerator is going to be 0. 0 over anything is 0, right? So this perfectly inelastic demand curve would have this elasticity of 0. That's the lowest value for this price elasticity of demand that we could ever see, which basically reflects that it doesn't matter what the change in price is, the percent change in quantity demand, people just keep buying the same amount. So this is the idea of, if I need a certain amount of insulin every month, I'm going to keep buying the same amount. It doesn't matter if they change the price by $5 or $10 this month. I need the same amount of insulin, right? So this is the idea of kind of a perfectly inelastic good, completely unresponsive, right? Inelastic, unresponsive to price changes. Any questions? Does this make sense? Any questions over this idea? I think here I've got just regular inelastic, right? So perfectly inelastic is if we get that elasticity of 0. We already said a good is inelastic if it has an elasticity of demand that's less than 1, right? So if it's less than 1, people are still fairly unresponsive, right? Because the only way our elasticity of demand was less than 1 was if that denominator was larger. So it would have to be that the percent change in price was much larger than the percent change in quantity. That would be kind of a relatively inelastic good. Because, you know, it's not zero. Zero is the perfectly inelastic good. So anything we gotta think about here, let's say I saw, why did I do 10? Oh, because I put less than 10. So right, we kind of had that on the board, the visual, right? Larger percent change in prices, smaller percent change in quantity demanded. That's kind of a good visual of our inelastic good. Okay? Then, you know, anything, price falls by 10%, percent change in quantity demanded is something less than 10. We know that our kind of elasticity measure will be less than 1. What if we had a unit elastic good? It would have to be that the percent change in price, right? Percent change in price fell by 10%. What would have to be true about the percentage change in quantity demanded? It was unit elastic. Said it earlier. Exact same. So here, price change was 10%. It had to be that quantity demanded went up by 10%. Exactly the same amount. Now when I divide the percent change in quantity demanded by the percent change in price, I get my elasticity of 1 every single time, if it's unit elastic. Now, usually, you kind of notice I've started out, go back here. Usually it'll be like, I'm trying to get the visual to line up with it. You can kind of see the area, right? That percentage change in price was greater here. Here I tried to draw them, or at least have them be like, look like the exact same percent change as well. They're kind of the same distance here. And then we'll go to inelastic demand. This starts to look more and more flat. Remember I said you can kind of think about relatively steep curves, usually represent something that's inelastic, so relatively flat demand curves. And I drew them here with some curve to it. I'll always keep them linear for us, right? Just a straight line. So you kind of think about here, if I saw the percent change in price of 10% to be elastic, right? Or have an elasticity of demand greater than 1. I know that it's really responsive. Being an elastic good is I'm very responsive to price changes. So price change of 10%, I would have to respond with my quantity demanded by more than 10%, right? And so that 10% price change now, if it's elastic, causes a much larger percent change in quantity demanded than just 10%. Now when I come up with my elasticity, it'll be greater than. And then we have the exact opposites. We had perfectly inelastic. What do you think a perfectly elastic demand curve would look like? So if it was perfectly elastic, this is kind of a weird thing to think about. But we said being elastic is anything greater than 1, right? So being perfectly elastic, the perfect inelasticity was 0, right? So like that was like the smallest value. Perfectly elastic would be like if I saw the highest value, which we can go off into infinity. Okay. So what this is going to look like is, think about, I've got some demand curve, right? For this to be an infinite, right, it would have to be that this percentage change in price, right, is actually 0. Right? So then if I have anything over 0, which actually take it in the limit, right? It's actually going to be approaching 0. I can actually divide by 0. And so we're going to end up with something that looks like this, right? Where I could see huge percent changes in my quantity demanded, right? But what happens to price here? If it's perfectly elastic, price doesn't have to change, and I can see people buy much higher amounts. Now, do we ever see this in practice? Nothing's perfectly elastic. Things can get really close, right? So we might have a demand curve that looks like this, right? Where I can see like really small changes in price cause really huge changes in percent changes in quantity demanded. But if it was perfectly elastic, it would be this horizontal demand curve. Okay, so in practice, do we see something that's perfectly elastic? Probably not. But we see things that do approach it. So I think I have a slide that kind of goes with that as well, not just what's up on the board. All right. Any questions over that one? So just this in general, we went through some kind of calculations. visual depictions, but why might, in the broader idea of things, why might we care about elasticity? Or the elasticity of demand? How responsive consumers are to price changes? Can't think of any reason why someone out there might be interested in that. If you're working for a company, hell, if you own the grocery store, right? Or a gas station, why might you be curious about the price elasticity of demand of certain products?
You might want to improve your profit margins, so you want to push as much as you can before consumers provide.
Yeah, right. What do I actually want people to do? If I was a producer selling something, would I want them to be, my consumers to be more inelastic or more elastic if I was trying to, let's say, increase the price of the good I'm selling? So if they're elastic, what happens? When I change the price by a little, I increase the price by a little, they buy way, way less if it's elastic. If it's inelastic, that means that when I could cause huge price changes, and they're not going to change how much they buy hardly at all, which is good for me. It means I'm selling like the same amount of the good at a much higher price. So as a producer or a seller, I'm going to care about this elasticity of demand because I want to be able to, hopefully my good is inelastic. And if it's not, then I need to be really, really careful by how much I'm changing the price, right? Okay. Get that idea kind of down. So I'm also going to start to think about how much time? 10 minutes. We'll talk through these, and I think I'll do something at the end. So let's say we've got different goods, right? And we want to think about, okay, it might be that different goods are more or less elastic, right? When we start to calculate these things. I kind of brought the idea. So one of the big things that impacts the elasticity of a good, or the elasticity of demand of a good, is how many substitutes are there, right? I brought up the example earlier of gas stations, right? Because especially in a city like Muncie, I mean, if you see one gas station, you can probably within, the vicinity see several others, right? Usually any, wherever there's one in Muncie, you can see a handful of other gas stations, or even just drive a mile or two and find another one, right? There's a lot of substitutes, right? So they can't just decide to change their price, because for a gas station, if you increase your price by say 20%, what do you think would happen in a town like Muncie? It's got several, plenty of gas stations around. Nobody's going to buy from them. So if they change their price, right, what's going to happen to their percent change in their quantity demanded? It's going to go from whatever it was basically to zero. So a huge percent change in their quantity demand. So if you have a lot of available substitutes, price elasticity of demand is relatively high. People are really responsive to price changes. If there's more options for me, I can be more picky, right? I can try to go out and see if somebody else has a lower price. Now, if I'm thinking about something like available substitutes, so if I have many, really similar substitutes, that's why I use gas station, because gas is gas, right? It's almost a perfect substitute. I'm going to have a more elastic good. You can think about fast food, cereal. We don't have a lot of substitutes. So the good I always like to think about, if I don't have a lot of substitutes, would be something like, I always use insulin, but it's, basically any drug that is patented that there literally is one of, right? There's no available substitutes. I have to have, this specific drug, right? Well, then it doesn't matter, or the EpiPen example, right? It doesn't matter what the price is. They can jack the price up and they know I have to pay it. That was like that, that was what the guy, what was his name? Martin Skellery or something. He's known as like Pharma Bro, right? He bought some pharmaceutical company. I forget what drug it was. It was like a certain disease that you needed it to survive, and it was the only drug out there because it was patented. And he jacked the price up, thinking I'm going to make a bunch of money, right? I mean, morally reprehensible, but right? He knew that people were not going to be responsive to that price change because they needed that drug to live. So, I mean, if you don't have any substitutes, you're going to have very inelastic demand, right? You could cause huge price changes and people don't have an option but to buy that good. You think about sporting events, right? Or very rare items, or another, good example where there's not many substitutes. So people are really, really inelastic to price changes. usually like electricity and things, there's only one provider. So you're just like, yeah, what am I gonna do? Not have electricity, right? I mean, I can change the amount I'm using, but I have to have electricity. The local utility could jack the price if they wanted to, which is why we have certain laws against regulating like local monopolies and things like that. We'll get into that kind of later on in the semester. So availability of substitutes is one of the determinants. The other is going to be the proportion of your income you spend on that good. So if I spend a lot of my income, right, on a specific good, do you think I'm going to be more or less responsive to price change? Might be easier to think about the other way around first. If I spend a very small amount of my income on it, so let's think about like a stick of gum or a pack of gum. If I am at a gas station and the cheapest pack of gum they have there is 25 cents, very small portion of my income, I'm probably going to buy it. If it's $1, I'm probably going to buy it, right? So there, going from 25 cents to $1 is a huge percent change in price, but because it's a relatively small amount of my income, I buy it a handful of times a year when I want a pack of gum from the gas station, right? I'm going to be pretty unresponsive to price changes, right? If it's a really, really small amount of my income, I'm not going to care if the price changes by a lot, right? Going from $1 to $2 is a huge percent change in price, but $1 to $2 is still a really small amount of my income, and so I'll probably still buy the same amount, or roughly the same amount, right? Not the exact same, but it won't change how much I buy very much. So that was kind of the idea of, I have a small portion of my income, I'm going to be less elastic, right? I'm not going to be as responsive to price changes. This was the idea of like a pack of gum or something, fountain drink or something like that. On the opposite end, if it's a high proportion of my income, like a house, what tends to happen when people are making housing decisions? They're really, really patient, right? And they'll wait months and months to find the perfect house, right? Or to find the perfect house at a reasonable price, right? They will be much more responsive when they're looking at the price of a home, right? Because it's a huge percent of their overall income. So how much the proportion of income influences demand as well. Any questions from this? If you want to think about this one, the easiest way to think about it is, it's going to be a relatively small percent of your income. You're not going to spend as much time thinking about it, right? I don't care about the price of a pack of gum near as much as I care about the price of the car that I'm buying, or the price of the house I'm renting, or whatever it is. Yeah, and Tom, I might pick up on this. I think we'll kind of go through some other determinants, but I want to kind of show you a couple of these, and we'll probably revisit these at the beginning of class on Wednesday as well. But these goods kind of give you, after we talk about all the determinants of elasticity, they kind of let you recall these. So like when I think about tobacco products, right? That's relatively an inelastic demand, right? It's a value less than 1. So what that's saying is that if you change the price, right, people don't really stop buying as many, a much smaller percent of cigarettes, right? They kind of are pretty consistent with how much tobacco they use, right, regardless of the price. Now, I mean, it's not 0, right? It's not perfectly inelastic, but it's relatively inelastic. Then when we have things like cars, right, brand new cars, we end up with really high elasticities, right? People are very responsive to price changes, right? If they can find a car that's, you think about it, even a small percent change in the price of the car, going from like 40 to 39,000, that's $1,000, but it's a small percentage change, right? But that $1,000 is a much larger percent of our overall income than like the change in matches, right? People don't care. If you need matches, you go to the store, right? They're relatively cheap, even a huge percent, they could double the price, and you're like, yeah, I'm still gonna buy a box of matches, right? So we'll walk through some other examples. We'll talk about different goods. And then I expect you to watch that video before we start class on Wednesday. It'll be up there on YouTube. It'll be talking about the relationship of elasticity to revenues. Okay, and we'll kind of tackle that next class as well. All right. All right. I will see you guys on Wednesday. Look for that next homework assignment up on Canvas as well.